Hi, everyone. I'm Pat Ross, a solutions engineer here at Analytics 8, and I'm excited to have you here today for our second event in our Databricks live stream series. Today, we're going to talk about some very important and practical ways to optimize your Databricks implementations for cost and performance. And I have with me here today Michael Kollman as our Databricks expert. Michael's a senior consultant here at Analytics 8, working with some of our most prominent clients to architect solutions using modern approaches and tools like Databricks. He has incredibly deep knowledge about Databricks, and I'm excited to talk with him about this topic today.
Yeah, Pat, thanks for having me. Excited to be here.
I'm excited you're here with me, buddy. So one of the reasons that we love Databricks is because of its flexibility and control, allowing organizations to tailor solutions to their specific data needs. However, without ongoing optimizations, you run the risk of having decreased performance or unchecked costs. So I want to talk about where to start when it comes to optimizing Databricks. So for our first question, let's start with the first most important things to know when it comes to optimizing.
Yeah, in my opinion, uh, as I've, learned throughout my career, you really need to understand the tools that you're working with, and you need to know the ins and outs, and you have to do the research on how things work to be able to optimize anything at the end of the day. And for Databricks specifically, it's all about knowing Spark, what Spark is, how it works, understanding Delta Lake, how Spark interacts with Delta Lake, the features that Delta Lake has that other table formats don't, and what you can take advantage of. And then, knowing Databricks, understanding the runtime, all the little tricks you can do in Databricks, understanding, even the UI, right? Like all the different parts of the UI that you can go in and tweak things and look at things. So you really just need to understand, the tools that you're working with in order to actually optimize anything.
Nice. So to reiterate what I heard, it sounds like your advice here is to make sure that engineers working in Databricks really understand Spark, really understand Delta Lake and Databricks itself. Um, and they need to have the confidence to navigate these tools, and business leaders should be dedicating enough time and resources to those engineers to make sure that they can get the most from their tools.
Yeah, absolutely. You have to know your tools that you're working with in order to do any sort of optimization.
Makes sense. So even if you understand the tooling and the code inside and out, how do you go about tackling a process like automation?
Yeah, I mean, you have to have a goal, right? You can have optimization in mind, but you need to know what you want to optimize. Are you trying to get more performance out of something? Are you trying to cut costs and see where you can optimize your spend? Or are you trying to do both at the end of the day? Because there's a lot of things you can do that will increase performance and increase costs or keep costs the same.
That's a great answer. Thanks, Michael. So next, I'd like to delve a little deeper into specific ways to optimize Databricks jobs. And let's start with a big one, clusters. How do you go about optimizing a Spark cluster?
Yeah, I mean, at first, kind of like what I was saying, you need to know the tools. So you have to understand what a cluster is. And really, it's just a bunch of computers that make up one bigger computer. So that way you have more resources to use. Now, these computers are referred to as nodes when you're talking about a cluster. So there's different nodes. And specifically in Databricks, you have, a driver node and worker nodes. And you kind of just need to understand what is going on your driver and worker nodes when you run code. Um, Databricks makes it really easy, right? You can just create a notebook, write whatever you want, and click run, and it does everything for you. And that's the beauty of it. But if you don't understand what's happening when you do specific things in your workbook, you don't know where the code is running. Is it running on the driver? Is it running on the workers? How do I utilize the workers? If you don't really understand what's going on, then there's no way that you can actually, start to optimize it. So, for example, Python, if you're just running pure Python code, like an API call or something, that's going to run on the driver node. Um, if you are actually utilizing Spark and doing some data transformations or reads or writes using Spark, that's when the driver node is going to execute or create a plan to execute all of that onto the worker nodes. So you have to understand, like the driver node is in charge of managing all of the workbooks and figuring out plans on how to use the workers and any of the Python code that you're running that, getting memory, getting data in and storing it as memory, that's all being stored on the driver. Whereas Spark is going to be utilizing the workers themselves.
So I think I kind of heard the beginning of the answer to my next question in there, but when would you want to increase the compute size of the driver node or workers over just adding more workers?
Yeah, so like I was saying, it really depends on, what you're running. So if let's say, for example, you have some Python code that's getting a bunch of data back from an API call. Maybe you're doing some stuff with it in Python, like, splitting some strings or, whatever you're doing, and you're doing it in Python and you're doing a lot of that work there, and then you're putting it into Spark and just using Spark to write to a table. And let's say you have multiple notebooks that do these kinds of things, or even if you have multiple notebooks that are doing all sorts of things, but you're running like, you can run up to like 50 jobs at a time. A lot
Mhm.
of the times your driver node is going to be a little overwhelmed by that. So if you're seeing something like a cluster crash and it's because it happens, you investigate and it's happening when, you have four workbooks running separate API calls, getting a lot of data back. That's a good sign that, maybe your driver node needs some memory increase. And the worker nodes themselves, if you're running some Spark code, like purely Spark stuff that's doing a lot of transformations, and you're seeing that you're maxing out your worker nodes all the time, and you have a lot of data that's being run in Spark, you might want to look at increasing the size of your compute on the workers themselves. So it's really just, understanding where your code is doing things and monitoring that, to figure out, okay, where am I seeing performance loss?
It makes perfect sense. And then what are some situations in which you might want to increase the number of nodes?
Yeah, so that's when you have, a lot of large Spark workloads at the end of the day. You always kind of want to start smaller, but if you have a lot of large workloads that are running and you're maxing out your cluster and all of your nodes are active, then that's when you want to really look into adding more workers. So that way you can, just have more compute power at the end of the day to distribute those tasks. And a lot of times when you add more workers, you need to look at like behind the scenes of what's actually going on. If there's like a lot of data shuffling or, you're doing a lot of aggregation, sometimes having more workers to split all those tasks up will help. And then, you can also just like check to see how things scale. Because at the end of the day, the way that Databricks bills things, it's based on compute time, right? So if you have a job that uses, two workers and it's taking an hour to run, and you think you've optimized all of your code, your Spark code, like you've done everything that you can, and you increase your worker count, there is a good chance that, using four workers is only going to take 30 minutes. So there's like a simple thing where you can increase performance without really increasing costs.
Yeah, no, that's a great tip. So you've mentioned why you might want to increase the compute or add more workers to your cluster, but how can you check to see whether you've made the right choice when you've done that? What are the signs to look out for?
Yeah, I mean, to me, cluster failures are number one, right? Like if your cluster is failing, if the driver is unresponsive, that's the number one telltale sign. And Databricks provides some really good metrics about this. So if you go into your compute layer in your UI, you can see a couple different things that are important. One is to check the event log first, in my opinion. Because if your cluster is failing, you can always go and check the event log and you can see where it failed, right? You can see that, maybe it'll give you like a message saying like the driver is unresponsive or something like that. So that's number one, saying, okay, there's probably something going on here that I need to further look into. And then next, what I would do is run whatever workload you're running and check the metrics tab, right? Because the metrics tab, and before the newer Databricks runtimes, you can use the Spark Ganglia UI to kind of get the same information. But the metrics tab is going to show you your CPU utilization, your memory utilization of your entire cluster, or you can break it down to specific nodes. So in the example before, when I was talking about if you're worried maybe your driver node isn't quite right, you can actually look at the driver node specifically to see how much memory is being used. You can see the CPU utilization. So you want to really just watch that all the time. And that goes also for the other way around, right? You want to make sure you're not underutilizing your cluster. Your cluster should remain at like an 80% load. Your memory should always be used when you're running these tasks, or else, maybe you have too much compute and you can actually scale down a little bit and save some money. So, it's all about just watching, what's going on in those metrics tabs themselves.
It sounds like there's some good tools for monitoring. How can those be used or leveraged maybe to optimize your cluster performance?
Yeah, I mean, you need to test at the end of the day, and it's not always the most fun thing to do, but you have to test. Whenever you're trying to make these optimizations for clusters or performance or anything, the number one thing you do, you can't just, figure out, oh, I think this is the problem, let's switch it and then let it go, right? You have to keep testing, you have to keep checking, you have to keep it in the back of your mind that, every once in a while, you should go in and you should check your metrics and make sure that your cluster's performing and your workbooks are performing as like you expect them to.
Nice. Are there any other quick wins or quick fixes while we're on the topic for cluster optimization within Databricks?
Yeah, those were some like detailed things we just talked about, but to me, there are a few things you should definitely check to see if you're running. Auto scaling and auto termination are the first two in my mind. They're pretty
Yeah.
simple. So auto scaling itself is when you start up a cluster, right? If you don't have auto scaling, you can set it. Let's say we have 6 workers, right? When you start up a cluster, all 6 of those workers are going to come online. And
Mhm.
whether you're using them or not, they're online and they're active. And you might not need them all, right? Like let's say you're running a small workload where you really only need like 2 workers. You have 4 wasted workers that you're just paying for and not using. Now, if you turn on auto scaling, you can set minimum and maximum worker counts, and then your cluster will scale to those sizes based on the need. So based on what you're doing. Um, and that's like a really good feature. The only downside, and it's a small downside, is that if you run a workload that you have like 2 clusters or 2 nodes active right now, and you need like another 4, like your driver figures out, I should turn on another 4 to get this job done. It takes a little bit of time for those clusters to spin up those extra nodes. Um, so that's like kind of the only downside, but it's really worth it in the long run. And then auto termination is essentially just shuts off your cluster if it's inactive, right? If nobody's using it, it'll just shut it off. The default time I think is 120 minutes, but you can set that to whatever you want, 10 minutes, 15 minutes, an hour, whatever you think is fine. Um, and then I guess I would say you have to use the jobs clusters where you can. I mean, that'll save you a lot of costs. There's most of the time they're fine to use. There are some situations where you might not want to use them, like if you have high frequency jobs running, because what it's going to do is spin up a cluster every single time a job runs. But at the end of the day, they're much cheaper. So if I was anybody, I would be utilizing jobs clusters where I can.
Yeah.
And for those high frequency workloads, serverless option that just came out, that's a good place to start as well.
Yeah, nice. Okay. Let's say you've done all these things and optimized the heck out of your Spark code and your cluster, but you're still looking to increase performance. We've all heard about Photon Engine. Lots of folks I've worked with are curious when and why to use it. Databricks boasts that it's a much faster compute engine. Can you tell us a little bit about what is Photon Engine and how can it help you?
Yeah, Pat, Photon Engine is really cool. Basically what it is I'll start with how they kind of came up with this idea to even create the Photon Engine. When they were, creating their Databricks runtime, in they were really just trying to optimize Spark as much as possible. And they
Mhm.
got to a point where they optimized it so much and they just ran into some barriers where they'd have to rewrite a lot of code or, like change a lot of things, or some things just wouldn't work and they weren't getting as much performance as they thought they could. So they decided to just kind of put Spark aside for a second and focus on building their own new engine, not in Java. They decided to build it in C++, so it's native code.
Mhm.
And Photon's really cool because it uses this thing called SIMD, and I'm going to do a very simple explanation of SIMD. There's a lot of things going on under the hood, right? But basically, SIMD, it stands for single instruction, multiple data. And what it is it's this way of writing a compute engine where you I'll give an example. So let's say you have two columns, column A and column B, and you want to add them or multiply them together, right, to make column C. In, a non-SIMD workload, like let's say you're using Spark, what it's going to do is, since that's like a scalar operation, it's going to look, each one of those data points that it's trying to multiply is going to be an instruction. Again, this is a very simple explanation. But what it's going to do is it's going to say, okay, row one, row two, multiply them together. That's our value for row one, column C, right? And it's going to do that for however many rows you need to do. Whereas what SIMD does is it's actually able to take those columns and multiply them together to give you a third column. So it like alleviates all the compute engine from like all those extra steps, and all those extra instructions. So it makes it really, really fast.
That's a great explanation. Thanks, Mike. How do you know when to use it or when it's right for you?
Yeah, so you really want to be looking for CPU intensive tasks, right? Like aggregations, joins, all these wide transformations, even like, your machine learning algorithms, like things that are like very CPU intensive, that you're utilizing Spark for right now. That's where you're going to see the biggest performance gains. And it's going to scale with data size, right? Like if you have not a lot of data, sometimes Photon, you're not really going to see the benefits of using Photon, right? But if you have a ton of data that you're doing these wide transformations on, you're joining tons of things together, you're doing so many aggregations, you're grouping data together, all of those types of things on large sets of data, that's where you're going to see the scale just rise.
All right, before we move on from Photon, anything else to be aware of?
Yeah, I mean it's I think it's around double the cost, last I checked. So you just, make sure you're aware of that. And it could save you money at the end of the day. You just, again, this goes back to testing. If you have these large data sets, if you think, a situation like I just mentioned is what you're doing and you could benefit from Photon, I would say definitely try it and check the costs. But typically, for smaller workloads, it might be more expensive than what it's worth. However, if performance is your goal at the end of the day and you're less worried about the cost of it, then definitely turn it on and try it out, see if you get some gains.
It makes sense. Okay, we've talked a lot about optimizing different kinds of compute, but one thing that we haven't discussed yet is Delta Lake. Can you give us some ways in which you can leverage Delta Lake features for optimization?
Yeah, Delta Lake has a lot of cool things, and at the end of the day, kind of like what I said when we started this call, you really need to understand what the tools are. So what is Delta Lake, right? Now it's a table format for, data lakes. But there's two main parts that I think we kind of want to talk about here is the underlying data itself and how that's stored, and then the features on top of the data itself. So it's kind of broken down into two pieces. So these features that, Delta Lake, has are a lot of them are located in a Delta log, right? And what that is that's like if you go into the backend, you'll see a folder called Delta log, and you'll have your Delta log in there. And what it is it's a transaction log essentially, and it holds a lot of like statistics, has a bunch of stuff in it. But the cool thing that they do is they keep statistics on each one of your underlying data files. So that way it knows like mins, maxes, like all these different statistics on the underlying data that's located in the actual data files. So what you want to do, I'll say this as well, it only by default keeps statistics on the first 32 columns. So you want to make sure that if you're filtering data by, columns that are, if things are being frequently filtered, you want to make sure that those are in the first 32, or you can change that setting. Just know that that'll add a little extra compute. You can either scale it down or scale it up. Um, but what it's going to do is it's going to collect statistics on those files. And those files are then, when your Spark cluster goes to read that Delta table, it'll know exactly which files it needs. So they call that data skipping, right? So it's able to actually skip tons of sets of data to pull it in, which that's a lot of IO. If it didn't do that, it would have to read in all of that data and then figure out what's actually in those files themselves to then filter. Whereas now it just needs to look at the Delta log and kind of figuring out, what's going on. So that's kind of the first half of how to get data skipping going.
Right. Awesome. So underlying data structure, very important for optimizing table reads. Are there any other features that we can leverage when we're creating a table to further optimize read-write performance?
Yeah, definitely. I mean, you want to look into liquid clustering and partitioning. So I'll kind of explain what those are. There is, I'm sure a lot of people have heard about Z ordering as well, but Z ordering is kind of the older version of liquid clustering. It's still fine to use, but liquid clustering is just kind of like a newer and improved version, I would say. They're a little different, but I think it's a little better. So that's what I've been recommending. But what liquid clustering is it's going to co-locate your data in the actual underlying data files, right? So if you are filtering, columns like, if you have a table with sales information, right, and you're filtering by store name and you're filtering by dates, and like you have some very common things that are people are using as filters to query, you're going to want to use liquid clustering and cluster that data with those columns that are, commonly being filtered. Because then when it actually stores the data together, it's going to store those records like near each other. So that
Mhm.
way, again, this goes back to like data skipping at the end
Data
of the
skipping.
day,
Yep.
right? Yeah, it goes back to data skipping. So now, like the data that you're filtering by is going to be near each other. So that way it has to read in less data, it has to parse less data to give you the results that you want. And so it's really cool. Liquid clustering also, you just turn it on and it'll cluster things going forward on writes. Um, if you have some optimization set up correctly, right? It'll just continue to cluster things. You can also change the keys over time. You can alter your table and it'll like dynamically like change the keys over time. So yeah, it's pretty cool. And then there's partitioning, right? I think a lot of people
Yeah.
know about partitioning. Um, so the thing with partitioning in Delta Lake and Databricks, you want to make sure you have a lot of data before you start partitioning, right? Databricks recommends anything over a terabyte of data in a singular table should be partitioned, or at least you should check out partitioning and see the performance differences. So you definitely want to like have a lot of data and you want to make sure that you're choosing the right partitions at the end of the day. Each one of your partitions should be around a gig because that's kind of the optimal size for Databricks to be reading in if you have a lot of data. You don't want a ton of partitions with a little bit of data. You don't want really big partitions because then that kind of defeats the purpose of partitioning it at the end of the
Right.
day. Right. So
Yeah.
yeah, partitioning is still alive and well, but we recommend liquid clustering a lot because we see a lot of clients that don't have tables with that much data in it, especially, nowadays with the compression that's out there using the Parquet files, great file format. Um, so yeah, we use that. There's also there's delta caching now that you can use. What that's going to do is if you have some optimized clusters like we talked about before, if you have some SSDs on there behind in the compute itself, you can actually cache some of that data when you pull it in onto the SSD itself, into memory. And then instead of having to go back and open those files, it reduces all that IO and that latency that you'll incur from that, and any of the read, latency that you'll see. If you cache all of that data, then you can use it a lot quicker.
Makes sense. Great things to keep in mind when you're building the structure of your table. I'd like to know, is there anything else we can do on more of an ongoing basis to make sure that our tables stay performant over time?
Yeah, that it's quite fitting for our talk. There's actually a command called optimize inside of Databricks in Delta Lake. And I think this one is really, really important. And I think a lot of people can see some of their biggest performance gains just by running this command. If you don't know what it is and have never used it, this could be really helpful. So what optimize does is it looks at all of your files, your underlying Parquet files that are in your data lake itself. And then what it's going to do is it's going to try and combine those together to get a target file size that's great for Spark to read in. So I'll back up and give an example, right? Like, let's say, actually, here's a good example that I saw recently. We had data coming in from an API, right? And it wasn't really that much data, right? Maybe 50, 100 records would come in from an API at a given time. And it was high frequency, so it was going on all the time. And it would read them in, our pipeline would read that in batches, right? And
Mhm.
then it would do whatever transformations needed, and then it would stick it into a table. And that was kind of the function of that part of the pipeline, right? So you can imagine there's a ton of transactions going on, right? You have, maybe let's say you have 100 transactions a day where you're reading in data and you're putting it in your data lake, and that's happening over, weeks, months, years, whatever. Now, what actually happened there is every time you bring in those 50 or 100 records and write them to your Delta Lake, if you don't have the auto optimize or auto compaction features on your Delta table, which I'll explain in a second, and you never run optimize, every single one of those Parquet files in the back end is only going to have like 50 or 100 records, right? So you're
Yeah.
just going to end up having a ton of really small files. And this goes back to data skipping. That's going to be
Yeah.
so you can't do any
A
data
lot of
skipping.
IO. Yeah.
That's so much IO that it has to like look at, read, and write. It's like, oh man, we have 5,000 files that we now need to read in right now. That's going to
Yeah.
take a lot of time, and they're all these tiny little files. So what Optimize will do when you run Optimize is it'll look at the actual backend data files in your table. It'll figure out what it can join together, and it'll join them all together to make bigger files. So that way, now when you go in and take a look to read in some data, there's way less files, and you can promote more data skipping and things like that. And in our example, I mean, that brought the query time down from 9 minutes to like a minute just by running the optimize command once, right?
That's
So
awesome.
if you don't have the auto optimize and auto compaction features on, so what those are they're table features that you can set when you're creating your Delta table, and they'll actually run they'll optimize on write. Okay, so what that does is it optimizes the data file size when it's writing. So if you have a bunch of data on all different nodes and you're writing it to a table, it'll before it writes them all separately, it'll figure out what's the best optimization to write them in the smallest amount of files. And auto compaction will then, once that's done, it'll then take a second look at all of the data files that you have to figure out what it can compact even further. So if you don't have those set up, which I recommend people set them up, first of all, when you're creating new tables. But if you don't have that, you can run the optimize command on a frequency that best suits you, right? So, it all depends on the frequency of the data and the size of the data. So you really need to figure out for yourself, what would be the best cadence to run this optimize command. But I would definitely recommend that everybody does that.
Awesome. Thank you. Well, unfortunately, I think we are starting to come up on time, but Mike, thank you for all these really helpful, very concrete takeaways that you provided with us today. I would like to wrap up with one final question. So we've talked in some detail about compute, clusters, Spark, Delta Lake, but is there anything else you want to share that we didn't have time to cover already or you feel is important when it comes to Databricks optimization?
Yeah, there's a couple cool things that you can do that I would definitely make sure I want to let people know to look into. Um, what we found some good performance gains in is multi-threading our Spark code. So, actually doing the multi-threading in Python to then distribute all those Spark tasks. We found that to be pretty helpful. You want to centralize your pipelines at the end of the day, right? Try to use, generic pipelines to do a bunch of different things, right? That's always a good thing to do. Don't overlook the general optimizations, right? Like we just talked a lot about detailed Databricks, Spark, Delta Lake things, right? But like do your due diligence when it comes to regular Python code. If you're running a lot of Python, right? Make sure you're using async, things like that. Make sure you're doing code reviews, right? Code reviews are always great because everybody has a bunch of knowledge on this stuff. So, make sure other people are looking at your code, see if they know a better way to do it. And finally, I always just say stay up to date with Databricks. I mean, they are always releasing things like liquid clustering came out, I don't know, maybe earlier this year, around this time last year. I'm sure they'll have new stuff soon. Serverless just came out, which can help optimize, cut costs. So just stay up to date with them. They're always releasing new things. I think they're working on a new Databricks runtime right now. I think 16 maybe. So I'm sure there'll be a lot more cool features in there. Yeah, but it's all about just staying up to date and figuring out what's going on with Databricks.
Awesome. Well, thank you everyone for joining today. And thank you again, Mike, for sharing this wealth of knowledge with us. Please feel free to connect with either of us on LinkedIn or email us directly to continue this conversation. We will be sending out a recording later today for you to revisit or share with your friends and colleagues. And if you haven't already signed up for our final webinar in this Databricks series, our CTO, Patrick Vinton, is actually doing a session, excuse me, next Friday on how Databricks makes it easier to add AI and ML capabilities to your data stack. And I hope to see you all there. Thank you.